I have collected few important questions from previous year exam papers and current CBSE sample paper. So friends, watch the complete video and write the answers in your copy. If you are new here, please subscribe the channel and press the bell icon for the future updates. First problem is show that the points A, B, C with position vectors 2i minus j plus k, I minus 3j minus 5k and 3i minus 4j minus 4k cap respectively are the vertices of a right angle triangle. Then we have to find out the area of the triangle. Friends, first of all we shall find the vector AB. Okay, how to get the vector AB? The position vector of B minus the position vector of A. That means I minus 3j minus 5k, obviously k cap, minus 2i cap minus j cap plus k cap. So that we are getting AB vector is minus I cap minus 2j cap minus 6k cap. Okay. Next we have to find out AC vector. The AC vector is equal to the position vector C minus the position vector of A. So we are getting 3i cap minus 4j cap minus 4k cap minus the position vector of A, that means 2i cap minus j cap plus k cap. So getting here AC vector is I cap minus 3j cap minus 5k cap. Similarly, the other vector BC. So BC vector will be got just subtracting the position vector of B from the position vector of C. So that we are getting 2i cap minus j cap plus k cap. Okay. So all the vectors are got. Now modulus of AB vector and its square will be minus 1 square plus minus 2 square plus minus 6 square. So we write it here minus 1 square plus minus 2 square and minus 6 whole square. So this is 1 plus 4 plus 36 is equal to 41. Next we find AC vector, its modulus and square. So this is 1 plus minus 3 square means 9 plus minus 5 square, that is 25, and the total is 35. Finally we are getting modulus of BC vector and its square is equal to 2 square, that is 4, plus minus 1 whole square means plus 1, and 1 square is equal to 1. So it is 6. Now friends, the vectors and their squares are respectively 41, 35 and 6. Now you see that if you add 35 and 6, you will get 41, isn't it? So since AB vector and its modulus square is equal to AC vector modulus square plus BC vector and its modulus square, so that we can conclude that ABC, the points A, B and C are the vertices of a right angled triangle ABC, isn't it? So now we have to find out the area of the triangle ABC. So how to get the area of the triangle ABC? So we know one formula actually. The area of triangle ABC is equal to half into modulus of BC into modulus of AC, isn't it? So this is equal to half. Modulus BC is equal to root over of 6, isn't it? So this is root 6, and modulus of AC vector in square is equal to 35. So its modulus, only just the modulus is root over 35. So we are getting root over 210 divided by 2 square units. This is the result. So first of all, we have shown that the triangle which is formed by the vertices ABC is a right angle triangle, and then we have found the area of the triangle. The area of the triangle is root over 210 divided by 2 square units. Our next problem is find the value of lambda if 4 points with position vectors A 3i plus 6j plus 9k, B I plus 2j cap plus 3k cap, and C 2i cap plus 3j cap plus k cap, and finally D 4i cap plus 6j cap plus lambda k cap are coplanars. First of all, we have to find out the vector AB. The vector AB is equal to the position vector of B minus position vector of A. One I have to write I cap plus 2j cap plus 3k cap minus 3i cap plus 6j cap plus 9k cap. So we are getting here minus 2i cap minus 4j cap minus 6k cap. Similarly, the other vectors, AC vector is equal to minus I cap, just subtracting the position vector of A from the position vector of C, that is from this one to this one. Okay, so we shall get minus I cap minus 3j cap minus 8k cap, and finally the vector AD. The vector AD is equal to subtract the position vector of A from the position vector of D. So we are getting I cap plus 0j cap plus lambda minus 9 k cap. The vectors, now one thing is very important, 3 vectors are coplanar. Suppose A vector, B vector and C vector, 3 vectors are coplanar, then obviously you know this formula that the scalar triple product of those vectors is equal to 0. That means square bracket ABC is equal to 0. Okay. So the vectors AB vector, AC vector and AD vector are coplanar if scalar triple product of AB vector, AC vector, AD vector is equal to 0. That is determinant of minus 2, minus 4, minus 6, next minus 1, minus 3, minus 8, and finally 1, 0, lambda minus 9. 1, 0, lambda minus 9 is equal to 0. So from this determinant we get minus 2 times minus 3 lambda plus 27 minus 0 plus 4 times minus lambda plus 9 plus 8 minus 6 times 0 plus 3 is equal to 0, or 6 lambda minus 54 minus 4 lambda plus 36 plus 32 minus 18 is equal to 0, or 2 lambda minus 4 is equal to 0. So finally we get lambda is equal to 2, hence the result. Our next problem is if A vector is equal to I cap minus j cap plus 7k cap and B vector is equal to 5i cap minus j cap plus lambda k cap, then find the value of lambda. So that A vector plus B vector and A vector minus B vector are perpendicular vectors. It is taken from CBSE 2013. So friends, first of all you have to find out A vector plus B vector is equal to, just add these two vectors and we get 6i cap minus 2j cap plus 7 plus lambda k cap, and A vector minus B vector, just subtracting B vector from A vector, we get minus 4i cap plus 7 minus lambda k cap. Okay. Since A plus B vector, this vector, and A minus B vector are perpendicular vectors, so we can write A vector plus B vector dot A vector minus B vector is equal to 0. Again I repeat, since these two given vectors a vector plus b vector and a vector minus b vector are perpendicular vectors, then obviously that dot product is 0. Okay, so from this one we shall get 6 into minus 4 plus minus 2 into 0, because there is no j vector, for this only 0, and finally 7 plus lambda into 7 minus lambda is equal to 0. So 6 4s are minus 24, and this is a plus b into a minus b. There is a formula, algebraic formula, a square minus b square. So this is 49 minus lambda square is equal to 0. So we are getting lambda square is equal to 25. Therefore lambda is equal to plus minus 5. Okay. So friends, since these two vectors are perpendicular on each other, so we have taken the dot product of these two given vectors is equal to 0. From this we have just a simple calculation. We got lambda square is equal to 25. Finally lambda is equal to plus minus 5. This is the result. Our last problem is, if a vector, b vector and c vector are three vectors such that a vector plus b vector plus c vector is equal to 0 vector, then prove that a vector cross b vector is equal to b vector cross c vector is equal to c vector cross a vector, and hence show that the scalar triple product of these vectors is equal to 0. And this is taken from CBSE sample question paper 2018. This is one of the most important questions of vector algebra. So we start. What is given? A vector plus b vector plus c vector is equal to 0. This is given. That is 0 vector. So friends, we multiply a cross a vector plus b vector plus c vector is equal to a vector cross 0 vector. Okay, so we know that a cross a vector is equal to 0 vector. So the other vectors will be taken, a vector cross b vector plus a vector cross c vector is equal to 0 vector. It implies that a vector cross b vector is equal to minus a vector cross c vector, so that getting a vector cross b vector is equal to c vector cross a vector. You know this rule of vector, that p vector cross q vector is equal to minus q vector cross p vector. So we have used this one, minus a vector cross c vector is equal to c vector cross a vector. Mark it 1. Next again we cross multiply b vector to both sides of the given condition. So friends, b vector cross a vector plus b vector plus c vector is equal to b vector cross 0 vector. Okay, it implies that b vector cross a vector plus b vector cross b vector is 0 vector, and finally b vector cross c vector is equal to 0 vector. It implies that b vector cross c vector is equal to minus b vector cross a vector, that is b vector cross c vector is equal to a vector cross b vector. Mark it 2. Okay, now from 1 and 2, we get a vector cross b vector is equal to c vector cross a vector, and this c vector cross a vector will be equal to b vector cross c vector, since b vector cross c vector is equal to a vector cross b vector. So we can write a cross b vector is equal to b cross c vector is equal to c cross a vector. Okay, we mark it 3. Now friends, this step is important, that is actually we have to find out the scalar triple product of A, B, C is equal to 0. Okay. So what is scalar triple product? You know, this form actually A vector, B vector, C vector is equal to A vector dot B cross C vector. This is the scalar triple product, and this is the notation of scalar, simple notation of scalar triple product. And we can write here A vector dot, what is B cross C vector? B cross C vector is equal to A cross B vector. So replace this one by A cross B vector. A cross B vector. Okay. So A dot A cross B vector means this is scalar triple product A vector, B vector. Now one thing is very important, this is actually 0. Why? Since scalar triple product of 3 vectors is 0 if any 2 vectors are same. For this scalar triple product is equal to 0. So finally actually we have got this one, the scalar triple product of A, B, C is equal to 0. This is our proof. Okay. So again I repeat the question and the final destination. If A vector, B vector, C vector are 3 vectors such that this is a given condition, A vector plus B vector plus C vector is equal to 0 vector, then we have to prove that A vector cross B vector is equal to B vector cross C vector is equal to C cross A vector. And hence we have to show that the scalar triple product of A, B, C is equal to 0. So from this given condition we have cross multiplied A vector to both sides and got a result, and next time we have multiplied the given condition on the both sides by B vector cross product and got the second condition, and combining these two conditions we got the first proof, A vector cross B vector is equal to B cross C vector is equal to C cross A vector. And finally we have found the scalar triple product of ABC, and we know the notation, the box of ABC is equal to A vector dot B cross C vector, and since B cross C vector is equal to A cross B vector, so we have replaced this one by A vector cross B vector. Finally we are getting A B vector, and this is obviously 0 since scalar triple product of 3 vectors is 0 if any 2 of them are equal. Hence the proof. Thank you. Have a nice day.